This is our strength and conditioning athlete assessment.
Our athlete is an 100-metre runner training 4 times a week and competing in both summer and winter seasons. The primary aim of this event is to cover the distance in the shortest time possible. The first element to the race is the mandatory crouch start, followed by an 100-metre sprint in a straight line. Internal demands include her physiological state, mental capacity, and her technique and biomechanics, impacting her focus and movement efficiency. External factors include environmental conditions, ground surfaces, and how physically fit her competitors are. Physical demands include explosiveness and power. Explosiveness is crucial for the start, as a good quick reaction time can account for up to 5% of the overall race time. Studies indicate a strong relationship between explosiveness and speed, as the power created from the propulsion phase helps increase their forward acceleration. Faster athletes have longer ground contact time, suggesting the power they create from this time is what enables them to run faster. Another physical demand is muscle mass. In sprinting, an athlete's ability to generate force quickly is crucial. The more muscle they have in their legs relative to their body weight, the better their performance and the faster they will run. Muscle mass is important in overcoming inertia and increasing stride length, both key factors in increasing speed. Flexibility, agility, and posture also impact an athlete's running technique, and optimal biomechanics are crucial when trying to maximize speed.
They had a mean height of 25.8 centimeters with the highest jumping 27 centimeters. A study on young female competitive sprinters observed a mean height of 33.8 centimeters, placing our athlete below this value, indicating that athletes had greater lower body strength and power, therefore producing more force and jumping higher. A study of 75 young female athletes displayed a low mean height of 27 centimeters, closely correlating with our athlete's ability. Athlete observed a mean height of 22.7 centimeters with the highest value of 24.4 centimeters. The high recorded by trained sprinters was 24.7 centimeters, almost identical to our athlete's highest jump, indicating good reactive strength. Our athlete's quickest contact time was 0.319 seconds, while the normative value is around 0.185 seconds, indicating slower force absorption. Our athlete's RSI was 0.7, while the normative data had a mean of 0.314. These values are quite lower, implying that our athlete had great relative strength and efficiency within her movement. 30% 1RM, our athlete produced a mean velocity of 0.74 meters per second, at 60% 0.60 meters per second, and 90% 0.33 meters per second. The normative data of strength trained female athletes showed that at 30% the mean velocity was 0.89 meters per second, at 60% 0.67 meters per second, and at 90% 0.38 meters per second. Both data sets displayed the force-velocity relationship, as with greater resistance from increasing load, more muscles activated to produce the movement, reducing lifting speed. Our athlete has similar values to the normative data, however, each mean velocity value was slightly smaller. As the study focuses on strength, trained athletes can be assumed they have greater lower strength and optimal technique. Athlete scored an 8 out of 9 in her overhead assessment, a 3 out of 3 for keeping her hands above her head while maintaining correct shoulder and thoracic positioning, a 2 out of 3 for hip, knee, and ankle alignment as she had a forward trunk lean and a slightly excessive hip flexion, however her knee and ankle remained in great control, a 3 out of 3 for her depth as her hip was below the knee and a neutral spine was maintained. A study of a deadlift functional movement screening displayed some similarities, as 76% of the participants also presented slightly excessive hip flexion. A large majority of participants had issues with their knees and ankles, affecting the triple extension alignment and limiting the depth required. Athlete had good lower body strength and full body mobility, resulting in great depth. She displayed good shoulder and thoracic positioning, which allowed her to keep the bar of her head and have full range of motion with sufficient balance and flexibility. She maintained good ankle and knee stability throughout each rep. Athlete displayed slighter weaker core body and lower body stability and mobility, as she had a forward trunk lean and excessive hip flexion. Insufficient muscle activity in these areas meant she wasn't able to move through her full range of motion with correct technique.
For strengths, the athlete showed strong relative strength in her lower body, concluded with her high RSI value in the drop jump. Relative to her sport, the athlete could deadlift a good load. Strength in her core was consistent, as it was embraced during her deadlift. She maintained a neutral spine and adequate full body form throughout her performance on both the deadlift and jumps. For deficits, the athlete had decreased explosiveness with slow contact time, meaning she absorbs force slowly. Lower mean velocity suggests weaker lower extremity strength and power. The athlete should focus on her initial landing in the drop jump to increase explosiveness. The conducted tests effectively evaluate athletes' force production, lower body strength, and overall stability, crucial for sprinters' explosive power and acceleration. Normative comparisons were specifically tailored to young female sprinters, confirming the test's relevance to sprinting performance. The athlete assessment tests and FMS are widely accepted and utilized testing systems. These tests offer valuable insights on the athlete's strength and mechanical efficiency, though not directly measuring speed. Reliability was ensured through consistent methods, equipment, and repeated trials. A larger sample size in the counter movement jump study enhanced reliability by evaluating numerous abilities. Repeating tests on multiple days could further enhance consistency by minimizing any covariant variables. Subjectivity in the AAA test may impose inter-rater reliability, but overall, these tests have been validated for having good to excellent test reliability.
Our SMART goal for power is to achieve a 10% increase in the counter movement jump in 8 weeks. The goal of enhancing output in the CMJ benefits performance by improving the ability to use the stretch shortening cycle during sprinting. The support phase of the jumping action in the CMJ closely mimics the eccentric concentric contractions of the leg extensor muscles during sprinting. This goal will ultimately allow the athlete to produce powerful movements with greater efficiency, leading to increased acceleration and strike length. Our SMART goal for movement quality is to improve posture and stability during the overhead squat to enhance movement quality and sprinting performance in 6 weeks. Athletes who perform poorly in the overhead squat test have impaired mobility and stability in lower extremity joints. By addressing the impairments identified in the overhead squat test, the athlete will be able to enhance movement quality in correcting forward lean and overextension of the hip. This will optimize performance in enabling for efficient movement mechanics. Our SMART goal for strength is to achieve a 10% increase in the 3RM deadlift within 12 weeks to enhance lower body strength. Improving deadlift strength will benefit the athlete by enhancing their ability to generate power from the lower body, leading to increased acceleration and stride power during sprinting. Winaki 2022 reiterates this, where the study concluded there is a strong correlation in the deadlift improving both sprinting and jumping ability, with the study concluding that deadlift improvements will result in increased sprinting performance. Our SMART goal for accessory strength is to improve vertical jump height by 10% to meet normative data averages in 8 weeks. By focusing on improving vertical jump performance as part of accessory strength training, this goal provides a clear and measurable target for enhancing explosive power relevant to sprinting. Compeller 2020 found that implementation of plyometric training will improve vertical jump ability and therefore contribute to enhanced lower body explosiveness, which directly translates to improved sprinting performance.
For power, 3 sets of 4 to 6 repetitions of box jumps exercise stimulates the concentric phase of sprinting and improves lower body power output. As power increases, the athlete can gradually increase box height. 3 sets of 3 to 5 repetitions of death jumps trains the stretch shortening cycle, a critical factor in sprinting power. Starting from a box, the athlete drops down before explosively jumping upwards. Depth can be adjusted based on experience. For strength, 3 to 4 sets of 6 to 8 repetitions of back squats strengthen the quads, hamstrings, and glutes. Proper form is crucial to minimize risks and maximize benefits. 3 to 4 sets of 4 to 6 reps of deadlifts strengthen the glutes, core, and hamstrings, targeting the posterior chain, which is vital for both injury prevention and sprinting power. These contribute to a solid foundation for explosive sprinting by increasing maximum force generation, leading to faster acceleration and overall improved sprinting performance. For accessory strength, 3 sets of 8 to 12 reps of calf raises target the calf muscles, contributing to a stronger explosive push-off during sprinting. 3 sets of 8 to 12 reps of single-leg Romanian deadlifts strengthens the hamstrings, glutes, and core while improving balance and stability, addressing imbalances between legs. 3 sets of 12 reps of lateral lunges strengthen the hip, abductors, and adductors, which is crucial for maintaining proper running form and preventing injuries. This program incorporates the dose-response relationship by gradually increasing training volume over time based on athlete progress and desired goals, following the progressive overload principle. This ensures continuous adaptation while minimizing injury risk and avoiding plateau.